All right, so I think this is recording. Let's take a look at this uniform motion problem. Um, Read the problem carefully and identify what you believe is thing one and thing two, and then press continue. All right, so I'm going to identify thing one as Mike and thing two as Larry. And obviously, you could have these backwards and be okay. All right, so now fill in as much information as you can in the table and identify your variable, what it's asking us for. Identify your variable as x. All right, and then press continue. All right, so let's fill out the table. Um, Mike is training for a marathon. He begins running at a rate of 6 miles per hour. So Mike's rate, 6 miles per hour. Larry is riding a bicycle. Larry travels faster, has a faster rate, 18 miles per hour. All right. It's asking us how long after Larry leaves will he catch up with Mike. So let's let the length of time that Larry's on his bike be X, and that has units of hours. Now, remember Mike took off an hour and a half before Larry did. He was running for an hour and a half, and Larry hadn't even gotten on the bike yet to take off after him. So Mike traveled longer, an hour and a half longer. I'm just going to write the hour and a half as 1.5. All right. Now, if they've left from the same place, and then Larry caught up to him, so they traveled the same distance. I don't know what that distance is, and they are asking me for it. It says how far have they both traveled, so eventually I will answer that. But the first question they asked was how long it took Larry, and that's what I called X. So that's what I'm going to find first, and then I can come back and find what that distance is. Now there's no indication to me that it's wanting us to do anything with the totals, to look at the total distance or the total time. It doesn't say anything about totals. So if for some reason I can't figure something out, I guess, we can add these expressions together, obviously, 2D and 2x plus 1.5, but I don't see a justification for doing that. All right. Now, go ahead. Of these four possibilities for uniform motion problems, pick the one that you think that we're going to use to relate the thing one and thing two, the information that we have in the table, and press continue. All right. So hopefully, if we're correct about not using the totals and not having information in the table, then we're not going to try to use those to set up the relationship. So hopefully you chose either the same distance or the same time. And if you didn't, go ahead and pick one now and press continue. Now, hopefully it's obvious that they didn't travel the same length of time, because Mike took off an hour and a half ahead of Larry. And since they left from the same place and Larry caught up to Mike, that they both traveled the same distance. So this is the relationship that we want to explore. Now remember that we have distance is equal to rate times time, and that time, if you rewrite that equation, is distance divided by rate. We're going to use the distance equals rate times time. So go ahead and write your equation. You use the information in the table to substitute in and write your equation, and then press continue. All right, so if the distance is rate times time, we want rate times time thing 1 and rate times time using information that we know about thing 2. So thing 1 had a rate, Mike had a rate of 6 miles per hour, and the length of time, x plus 1.5. Thing 2 had a faster rate, Larry on his bike, and the length of time is x. So there's our equation. Go ahead and solve that equation and then press continue. All right, so hopefully you simply distributed the 6 through the binomial. And subtracted 6x from each side. And divided by 12, and then reduced the fraction to 3/4. So 3/4 of an hour. So it took Larry 45 minutes, or 3/4 of an hour, to catch up to Mike. Now, that's not the only thing it asked us for. How far did each of them travel? So go ahead and figure that out, and then press continue. All right, so remember that I can use either the left-hand side or the right-hand side of the equation. Each of those is the distance. And so let's just go ahead and simply take 18 times 3/4. So the distance that they traveled, 18 times 3/4. 27 over 2. 13.5 miles. All right, so have we answered what they wanted us to answer? How long does it take Larry to catch up to Mike? And 3/4 of an hour. How far did each of them travel? 13.5 miles. So we answered both of them. All right, well, I hope that helps, and I'll talk to you later. Bye.